Hi students, today I am going to discuss about the particulate pollutant, then the particulate pollutant like fog, smoke, smog, mist like this. Then the photochemical smog, ozone layer, the ozone fold, these things we are going to see in this video. After that, the water pollution, the type of water pollution also we are going to see in this video. Now we will start the lesson. See, the particulate pollutants mean such as dust, mist, fumes, smoke, smog like this. So these are called particulate pollutants. Usually the small solid particles and liquids droplets suspended in air are collectively called particulate. Then some important characteristics of the particulate pollutants like size, then mass, concentration, surface area, then the chemical nature of the substance. Here first the size. Their size varies from that 5 nanometer to 5 lakhs nanometer like that. Then that is mean the size mean diameter. Then mass, the masses varies from 60 microgram to 2000 microgram, then the per meter cube is urban and the industrial areas. Then the concentration. The concentration, their numbers varies from few hundred per centimeter cube in the clear air to the 10 power 5 per centimeter cube in the polluted air. So this is the main concentration of the particulate pollutants. Then the surface area, they have a large surface area due to which they have a good absorption for the organic as well as the inorganic matters. Then the chemical nature. The chemical nature is different types of the particulates have a different chemical natures. And then sources of the particulate, usually natural sources, then man-made sources, these things are there. First the natural sources, including the volcanic eruptions, grinding, blowing of dust and the soil by the wind, spraying of salt by seas and the ocean like this. This is the natural sources. Then the man-made sources include a large number of materials suspended there, air as particular, like example soot, then fly ash. Inorganic particulates mean few common inorganic particulates like metallic particulates, metallic oxides, lead halides, asbestos dust, sulfuric acid and the nitric acid like this. So these are the different types of the source of the particulates. See, we'll see the smog. There are two types of smog. One is the classical smog, then the photochemical smog. Usually the word smog is derived from the smoke and fog. So this is the most common example of air pollution that occurs in many cities throughout the world. Usually these are classified into two types. One is classical smog and the photochemical smog. First, the formation of a photochemical smog we will see. Before that, what is that classical smog we want to know? That classical smog occurs in the cool humid climate. It is mixture of smoke, fog and the sulfur dioxide. Chemically, it is a reducing mixture and so it is also called the reducing smog. Then the photochemical smog. The photochemical smog occurs in warm, dry and sunny climate. Then the main components of the photochemical smog result from the action of sunlight, and that's the action of sunlight and unsaturated hydrocarbon and nitrogen oxide produced by automobiles and the factories. The photochemical smog has high concentrations of the oxidizing agent and is therefore it is called oxidizing smog. The first one, classical smog, is also called reducing smog. The photochemical smog is oxidizing smog. Then the formation of the photochemical smog. When the fossil fuels are burned, a variety of the pollutants are emitted into the earth in the troposphere. There are two types of the two of the pollutant that are the emitters are hydrocarbons and the nitric oxide. Hydrocarbons and the nitric oxide. When these pollutants build up the sufficiently high levels, a chain reactions occur from their interaction with sunlight in which that nitrogen monoxide is converted to the nitrogen dioxide. Then this reaction, the NO2 is turns absorb energy from sunlight and break up into nitric oxide and free oxygen atoms. Then the oxygen atoms are very reactive and combined with O2, to form ozone. The ozone is formed. This reaction rapidly react with the nitrogen monoxide to regenerate the NO2 gas and the oxygen gas. See, ozone is a toxic gas and both of the nitrogen dioxide and the ozones are the strong oxidizing agent and can react with unburned hydrocarbons in the polluted air to produce the chemical such as the formaldehyde, then polyacrylonitrile, acrylonitrile, these things are produced. The hydrocarbon, the methane react with the ozone to form this formaldehyde. Then the formaldehyde then forms acrolein peroxyacetyl nitrate, which is called PAN. Okay. Then the effects of the photochemical smog is the common components of the photochemical smogs are ozone, nitric oxide, acrolein, then formaldehyde, and that peroxyacetyl nitrite. The photochemical smogs causes serious health problem. Then the both ozone and the peroxyacetyl nitrite, which is called PAN, act as a powerful eye irritants. So ozone and the nitric oxide irritate the nose and throat, and their high concentration causes headache, chest pain, dryness of the throat, cough and difficulty to the breathing. Then the photochemical smog leads to cracking of rubbers and extensive damage to the plant life. This also causes corrosion of metals, stones, building materials, rubbers and painted surfaces. Okay. How can be the photochemical smog will be controlled means many techniques are used to control or reduce the formation of the photochemical smog. If we control the primary precursors of the photochemical smog like nitrogen dioxide, that is NO2 and the hydrocarbon, the secondary precursors such as ozone and the peroxyacetyl nitrate, then the photochemical smog will automatically be reduced. So usually catalytic converters are used in the automobiles, which prevent the release of nitrogen oxide and the hydrocarbons to the atmosphere. Okay. Then we'll see the stratospheric pollution, formations of and breakdowns of the ozone molecule. Stratospheric pollution, the formation and the breakdown of the ozone molecule. See, the upper part of the stratosphere, consists of the considerable amount of ozone which protects us from the harmful ultraviolet radiation, that UV radiation. Frequency, the wavelength is 255 nanometer coming from the sun. So these radiation cause skin cancer in humans. Therefore, it is important to maintain the ozone shield. The ozone in the stratosphere is a product of the ultraviolet radiation acting on dioxygen molecules. The ultraviolet radiation split apart molecular oxygen into free oxygen atom, like that. These oxygen atoms combine with form molecular oxygen to form ozone. So this is the formations of the ozone molecule. The ozone is thermodynamically unstable and the decomposes to the molecular dioxygen. Then the dynamic equilibrium exists between the production and the decomposition of the ozone molecules. The recent years there have been reports of the depletion of this protective ozone layer because of the presence of certain chemicals in the stratosphere. The main reason of the ozone layer depletion is believed to be the reason of mainly the releasing of the chlorofluorocarbon compounds, CFCs. It's also called ferrons. These compounds are non-reactive, non-flammable, non-toxic organic molecules, and therefore used as a refrigerator and air conditioner in the production of the plastic foam and by the electronic industry for the cleaning computer parts like that. Here that CFC, chlorofluorocarbon, are released in the atmosphere. They mixed with the normal atmospheric gases and eventually reach the stratosphere. So in stratosphere they get broke down the powerful UV radiations, releasing the chlorine free radical. This is the chlorofluorocarbon react with the UV light to form the chlorine free radical is formed. The chlorine free radical react with the stratospheric the ozone to form the chlorine monoxide. That chlorine monoxide radical, this indicates radical. Chlorine monoxide radical is formed. The chlorine radicals are continuously regenerated like this. Regenerated and cause the breaking down of the ozone. So the CFC of chlorofluorocarbons are transporting agents for the continuously generating chlorine radicals into the stratosphere and the damaging the ozone layer. Next we will discuss the ozone fold. The ozone fold. Here in 1980s, the atmospheric scientists working in the Antarctica reported about the depletion of the ozone layer, commonly known as the ozone hole over the South Pole. It was found that unique set of condition was responsible for the ozone hole. In summer season, nitrogen dioxide and methane react with chlorine, the chlorine monoxide and the chlorine atoms like that. The chlorine atom is already we seen that. The chlorine atom is forming chlorine zinc. Sinks, then preventing much ozone depletion, whereas in winter the special type of clouds called polar stratospheric clouds are formed over Antarctica. So these polar stratospheric clouds provide surface on which chlorine nitrate formed. The chlorine nitrate is formed. This is the chlorine nitrate. The chlorine nitrate is formed, released with that gets hydrolyzed to form the hypochlorous acid. Usually this hydrolyzed undergoes to form hypochlorous acid. This hypochlorous acid is also react with the hydrogen chloride to produce again to form that chlorine radical, react with the methane to form the methyl radical like that, to give the molecular of the chlorine. That means the the chloronitride react with the HCl gas to form the chlorine, okay, the molecular of the chlorine. Then here the next reaction that hypochlorous acid, when the sunlight that returns to the Antarctica in the spring, the sun swarms breaks up the clouds and the hypochlorous acid and the chlorine are photolyzed by the sunlight. Then so this is the given reaction like this. The hypochlorous acid, when treatment with the sunlight, what happened? That hydroxide radical and the chlorine radical is formed. Okay, then the chlorine gas to break down in the chlorine radical is formed. That chlorine radical thus formed that initiated the chain reaction for ozone depletion as the described already that earlier. This effect of the depletion of ozone layer is the depletion of ozone layer more in the UV radiation filters into the troposphere. The UV radiation led to the aging of skin, cataract, sunburn, skin cancer, then killing of many photoplanktons, then damage to the fish productivity like this. So it has also been reported that the plant proteins get easily affected by UV radiation, which leads to the harmful mutation of cell. It's also increased the evaporation of surface water through the stomata of the leaves and the decreases the moisture content of the soil. So increase in the UV radiations damage the paints and the fibers, causing them to the fade is faster. Then next is a water pollution. The water pollution, mainly the water is essential for life. Without water there would be no life. We usually take water as a granted for its purity, but we must ensure that quality of water. The pollution of water originates from human activities. Through different paths, the pollution reaches surface or groundwater. Easily identified source or place of pollution is called as point source. Example, the municipal and the industrial discharge pipes where the pollutants enter the water source. Non-point source of pollutions are those where a source of pollution cannot be easily identified. Example, the agriculture runoff, acid rain, stormwater drainage, there is stormwater drainage, then like this. So these are the major water pollutions. Then the causes of the water pollution, mainly the pathogens, organic waste, then the chemical pollutants. The first, the pathogens. The most serious water pollutants are disease causing agents called pathogens. The pathogens include bacteria and other organisms that enter water from domestic sewage and animal excreta. So here the human excreta contains the bacteria such as Escherichia coli and Streptococcus faecalis, which causes the gastrointestinal disease, simply gastro diseases. Then the organic waste. The organic waste is the other major water pollutant, the organic matter such as leaves, grass, trash, like that. They pollute water as a consequence of runoff. The excessive phytoplanktons growth within the water also cause water pollution. So these wastes are biodegradable. The large pollution, the large population of the bacteria decomposes organic matter present in water. They consume oxygen dissolved in water. The amount of oxygen that water can hold in the solution is limited. In cold water, dissolved oxygen can reach the concentration up to the 10 parts per million, the 10 ppm, whereas the oxygen is air is about 2 lakhs ppm. That is why even a moderate amount of organic matter when decomposed in water can deplete the water of its dissolved oxygen. The concentration of the dissolved oxygen in water is very important for the aquatic life. If the concentration of dissolved oxygens of water is below 6 parts per million, the growth of fish gets inhibited. Then the oxygen reaches water either through the atmosphere or from the process of the photosynthesis carried out by many aquatic green plants during daylight. However, during night, photosynthesis stops, but the plants continues to respire, resulting in the reproduction of the dissolving oxygen. The dissolving oxygen is also used to microorganisms to oxidize the organic matter. If too much of the organic matter is added to the water, all the available oxygen is used up. So this causes the oxygen dependent aquatic life to die. So this anaerobic bacteria being to break down the organic waste and they produce chemical that have a foul smell and harmful to the human health. The aerobic bacteria degrade these organic waste and keep the water depleted in the dissolved oxygen. Then the amount of the oxygen required by the bacteria to break down the organic matter present in the certain volume of sample of water is called biochemical oxygen demand. The biochemical oxygen demand, that amount of biochemical oxygen demand in the water is a measure of the amount of organic materials in the water in terms of how much oxygen will be required to break it down biologically. Clean water would have the biochemical oxygen demand value of less than the 5 parts per million, whereas the high polluted water could have the biochemical oxygen demand value is 17 parts per million or more. Then the chemical pollutants. The chemical pollutants, as we know that the water is an excellent solvent, water soluble inorganic chemicals that include heavy metals such as cadmium, mercury, nickel, like this. The constituent as important classes of the pollutants. All these metals are dangerous to human because our body cannot excrete them. Over the time, it crosses the tolerance limit. So these metals can damage kidneys, central nervous system, livers, like this. Then the acid from mine drainage and salt from many different sources, including raw salts used to melt snow and ice in the colder climates, are water soluble chemicals, pollutants. Okay. Major of the water pollution pollutants, microorganism sources, domestic sewage, organic waste like sources, domestic sewage, animal excreta and waste, decaying of animals and plants, discharge from food processing factories, like that. Then the plant nutrients in the chemical fertilizer sources. Then the toxic heavy metals like industrial, the sources is industrial and the chemical factories. Sediments, the sources is erosions of soil by agriculture and strip mining. Pesticides, the chemical used for killing insects, fungi and weeds. Then the radioactive substance, like mining of uranium containing minerals. Then the pollutant heat minus the sources, water used for cooling the industries. So these are the major water pollutant. Next is the international standard for the drinking water. International standards for the drinking water. We must follow the international standard for the drinking purposes, like this. First, fluoride. For a drinking purpose, water should be tested for fluoride ion concentration. A deficiency in drinking water is harmful to the man and causes disease such as tooth decay, like that. The soluble fluoride is often added to drinking water to bring its concentration up to 1 parts per million or 1 mg decimeter cube per decimeter cube. That fluoride ions make the enamel on teeth much harder by converting hydroxypytate that enameled the surface of the teeth into the much harder fluoropytate. Okay, so that however we have to use that fluoride ion concentration above 2 parts per million causes brown mottling of teeth. At the same time, the excess of fluoride causes harmful effect to bones and teeth, as the reported for some parts of Rajasthan, like that. Then the metal lead. The drinking water get contaminated with lead when lead pipes are used for the transportation of water. The prescribed upper limit of the concentration of lead is drinking water is about 50 ppm. So that the lead can damage the kidney, liver, reproductivity system, like this. Then the sulfate, excesses of sulfate in drinking water causes laxative effect, otherwise at moderate level is the harmless. Then nitrate, the maximum limit of nitrate in the drinking water is 50 parts per million. Excess of nitrate in the drinking water can cause diseases such as methylmegalobinemia, like that is blue baby syndromes. Then the other metals, the maximum concentration of some common metals recommended in the drinking water, like this. This is the maximum prescribed concentration of some metals in the drinking water. Iron, the maximum concentration is 0.2 ppm. Then manganese is 0.05 ppm. Aluminium is 0.2 ppm. Copper 3.0 ppm. Zinc 5.0 ppm. Then cadmium is 0.005 ppm. Hello students. Today we were discussing about the particulate pollutants. Then the ozone fold, we were seeing how the ozone layer is damaged. Then water pollution, the different types of pollution, the photochemical smog. So these things we were discussed today. Go through this video very carefully.